Okay, this warm-up is over factor by grouping. That's what we did Friday. I would like for you to pause the video one problem at a time. So go ahead and pause now. Work one and or two, however you want to do it, and then unpause the video when you're ready to see answers. Remember, you group the first two together and the second two. You GCF the first group. Their coefficients have nothing in common, and the most x's they have in common is 2, so we write x squared outside. We write the leftover factors on the inside. We're left with 2x plus 5, and you can always check yourself there by distributing. Then on the second group, we're going to lead with a minus sign. 6 and 15 have 3 in common. There are no x's in common, and there's one y. So that's their GCF, 3y. Open parentheses for the leftovers. That's left with 2x plus 5. Remember, it's kind of like a division. So we had a negative 15 divided by negative 3, and that's how we get this positive 5, because it's like distributive property for division. And now we take the GCF of both groups together. So what they have in common is the 2x plus 5, so we write their GCF here, and we write their leftover factors in parentheses. We're left with an x squared minus 3. And you could do double distributive or FOIL to check your answer there. Pause the video now if you want to work number 2 before you see the answers. For the second problem, you probably got started on the first group correctly, but then let's look at the second group. We have a plus x minus 7. It kind of looks like they don't have anything in common. But don't forget, just because they're prime, prime numbers have factors of itself and 1. So in this case, we have to put something for a placeholder. So what I'm going to put on the outside, I'm going to put plus 1 is what they have in common. And if you're unsure of the sign, like if you thought, does this need to be positive or negative, just write something down and then check yourself. If I check the plus 1, I have plus x minus 7, which is where I want it to be. And so now they have an x minus 7 in common, and their leftover factors are 3x squared plus 1. So for today's lesson, you should have already picked up a note page when you came in. Today's lesson is factor by grouping, kind of. We are going to look at trinomials, which means there are 3 terms. We're going to set it up as a factor by grouping. Notice in the warm-up, the factor by grouping had 4 terms going on. It had 1, 2, 3, 4 things. But I just told you we're going to factor trinomials by grouping. So what that means is we're going to rewrite the trinomial meaning 3 things. We're going to rewrite it as 4 things and then do the factor by grouping. But I want to start you off by first showing you this FOIL problem or double distribute. I've got 2 factors here. I have 3x plus 2 as a factor and 2x plus 1 as a factor. If I'm multiplying them, okay, this process going forward, I distribute the 3x, that gives me 6x squared plus 3x, and then I distribute the positive 2, that's 4x plus 1. There's something that I want you to notice here. These terms can be combined. These are like terms. And so my final answer is 6x squared plus 7x plus 1. So what we just did is multiplied factors to get this answer. What I'm going to show you now is how to use something called the AC method to factor this, 6x squared plus 7x plus 1. So pretending like this is our beginning point, I'm going to show you how to go from here to here. And this practice is called factoring, because we're taking 3 terms that are being added and rewriting it into 2 things that are being multiplied. Hence, they're factors. So that's why the method is called factoring. So we already know what that answer is going to be. 3x plus 2 times 2x plus 1. let me show you how to get that using the AC method. So I'm right here at this example. I've got the steps here. It says use the AC method to factor 6x squared plus 7x plus 2. Step 1 is to factor out any GCF. But if you look 6, 7, 2, and at all the x's in each term, there's nothing that they all three have in common. So this step for now is not applicable. So I go to the second step. Find two numbers that multiply to a times c and add to b. Well, what does that even mean, a, c, and b? So here's where I want to bring your attention to the standard form right here. That is standard form for a trinomial, where a is the coefficient for x squared, b is the coefficient for x, and c is your constant. So if I'm looking at this example problem here, a is 6, b is 7, and c is 2. So when step 1 says find two numbers that multiply to a times c, that means 6 times 2. And add to b means adds to 7. And the way I generally set that up is I just do a cross out here somewhere. And here I'm going to put the a times c part goes here. And the b part goes here. So my a times c is 6 times 2, which is 12. And I wanted to add to b, which is 7. So what two numbers multiply to 12 but add to 7, and that's 3 and 4. Okay, so step 2 is 3 and 4. Now that might seem like some kind of magic, voodoo, random arbitrariness, but here's where I want to bring your attention to the thing we did in the warm-up. Where do you see 3 and 4 in the warm-up, or in the example problem? Here and here. And that added to the middle term 7x. So it's not a coincidence that we came up with 3 and 4. We're working backwards. We're working from here to here to here. That is our goal for factoring trinomials. And so now that we've just found 3 and 4, what we're going to do is now step 3, split the middle term using those two numbers. So I go back to my original trinomial. The first term and the last term stay the same. I'm splitting the middle term. I'm rewriting it with the 3 and the 4. So 7x becomes 3x plus 4x. And now the last step is to factor by grouping, which we're ninjas at that now. Okay, so I factor by grouping. I group these. Now the first group has 3x in common. And the second group has a 2 in common. The GCF of both groups is 2x plus 1. And then we have 3x plus 2. Okay, which is exactly what we knew we needed, because that's what we started off with in the example problem. Notice in the example problem, the factors are out of order. 3x plus 2 is listed first. Don't forget, for multiplication, because this is two things being multiplied, group 1 and group 2, those two binomials are factors. They're being multiplied. The property that says that the order doesn't matter for multiplication is commutative. We learned that at the beginning of the year. Remember, the order of my commute to work doesn't matter. So the order for multiplication and addition does not matter. So that's commutative. So using this example and those steps, I want you to work the rest of the problem. There are 3 on this front side and 4 on the back. I'm going to work them all in the video without a lot of talking about it. I'm just going to show you. So what I want you to do is pause before you're ready for each problem. Look at the work, and then pause again before you're ready for the next one. Actually, I'm running out of time for the video. What I want you to do is I'm going to have the key in the back, and I want you to check yourself with the key, or hopefully before class, maybe I'll have time to run copies of the keys. Sorry about that, you guys. I'm running out of time. We have a staff meeting.